Hello everyone, welcome back to my channel High Mathematics. Today we have a very interesting exponential equation from entrance examinations, 3 to the x plus x equal to 11, and we need to find our x. So first of all, let's write this x on the right side with the negative sign. So as a result, what do we have? This is our first step. We're going to write it as 3 to the x equal to 11 minus x. Here's our first step. Right now, let's divide both sides by 3 to the power x. Okay, so we're going to divide both sides by 3 to the power x. Let's do this right now. So as a result, what do we have? We have 3 to the power x. We're going to divide by 3 to the power x and equal to 11 minus x. We're going to divide it by 3 to the power x. Right here on the right side, this is obviously like equal to 1 because we have the same numerator and denominator, so we can easily cancel this. As a result, what do we have? We have 1 on the left side equal to, right here, what do we have? 11 minus x, we're gonna leave it in a numerator, but 3 to the x, when we have like a expression like we have like 1 over m, we can easily write it as m to the power minus 1. So we can easily write it in our numerator. So as a result, we can write it as 11 minus x, and 3 to the power x we bring to our numerator. So as a result, we can write it as 3 to the power minus x. Okay, so this is our first step. And for better understanding, I'm going to swap this left and right side because we have equal sign and we prefer our constant on the right side. So we're going to swap positions. So as a result, we have 11 minus x times 3 to the power minus x equal to 1. So here's our equation after our first step. What are we going to do next? Right now, let's multiply both sides by 3 to the power 11. Let's see what will happen. Don't ask me why. This is a very tricky moment, and in a few seconds you will understand why I multiplied both sides by 3 to the power 11. So let's multiply both sides by 3 to the power 11. What do we have as a result? We will have 11 minus x. Right here, we're going to write this 3 to the power 11, so times 3 to the power 11. We still have times 3 to the power minus x. So as you can see, we just multiply this left side by this 3 to the power 11. And equal to, what do we have right here? 1 times 3 to the power 11. And right now, let's look closely right here. What do we have? We have same base but different powers. And it doesn't matter when we have multiplication. When we have multiplication different, the same bases but different powers, we can easily add our powers. Okay, so that's why I multiplied both sides by 3 to the power 11. So as a result, what do we have? 11 minus x in the beginning. The next thing, what we had? We have times 3 to the power 11 minus x. As you can see right now, we have the same value, the same expression right here and the same expression right here. So it's great moment right now, and equal to 3 to the power 11. And right now, the few words about the thing the thing which is called like Lambert W function. This is extremely important like theorem in our case because it helps us a lot. So when we have like a Lambert W function of a times e to the power a, when we have the next expression, this is equal to a. So this Lambert W function helps us to simplify our expression. So if you don't understand this Lambert W function, just look at this expression. So when we have Lambert W function, for example, of 2 times e to the power 2, this is equal to a. As you can see, absolutely the same expressions in our example and in our general case. So as a result, this is equal to a, but a equal to 2. So this Lambert W function simplifies us a lot. It helps us a lot to simplify expression, but we need to create a great expression for applying Lambert W function, because right here we need to have e. We need to have the same expression in front of this e and at the power of e. Yeah, so when we have this type of expression, we can easily apply Lambert W function. In our case, as you can see, we have the same expression right here and the same expression right here, but we have 3. In our case, we need to have e. So we need to create e. But how can you do this? Very tricky. I'm going to show you a very tricky move. So instead, in terms of these 3, let's write e to the power natural log 3. This is equal to 3, yeah, in terms of like natural log. We can easily cancel this e and this natural log 3. So right now, instead of this 3, let's write e to the power natural log 3. Let's do this right now. So we have 11 minus x. In terms of this, instead of this 3, we're going to write e to the power natural log 3. So times e to the power natural log 3, and we need to raise this to the power 11 minus x. Don't forget about it. So 11 minus x, we still have this power, equal to 3 to the power 11. So I hope you understand this step. It changed nothing. Instead of this 3, I just write this e to the power natural log 3. Right now, we have a to the power x raised to the power y. We just need to multiply it, a to the power x times y. So here is our property. I don't want to write this property because this is basic school property. We just need to multiply these powers. So let's do this right now. So we have 11 minus x times e to the power natural log 3 times 11 minus x, and equal to 3 to the power 11. Okay, so we just multiply our powers. And right now here is the tricky move. We have e right here. So e is great. We just completed this part with e. But we have this is our a, for example, but this is not our a. Or say it in other words, natural log 3 11 minus x. This is not the same as right here. But what we need to do to create the same expressions as a power and in front of this e, we just need to multiply it by natural log 3. Okay, when we multiply it, so just look at it. So when we multiply both sides by natural log 3, when we multiply it, we will have on the left side, we will have natural log 3 11 minus x times e to the power natural log 3 11 minus x and equal to 3 to the power 11, yeah, times natural log 3. So we just multiplied both sides by this natural log 3. But right now let's look closer right here. We have natural log 3 11 minus x. We have natural log 3 11 minus x. Absolutely the same expression. So just keep in mind that this is our a, this is our a. So in terms of like this formula, this theorem, this Lambert W function definition, we can easily apply Lambert W function. So let's do this right now. So Lambert W function of this long expression. So we have natural log 3 times 11 minus x times e to the power natural log 3 times 11 minus x, yeah, and equal to, so right here we need to close this parentheses, equal to Lambert W function of 3 to the power 11 times natural log 3. All right, right now let's look closely. Natural log 3 11 minus x. This is our a. Natural log 3 11 minus x, absolutely the same thing. This is our a, and we have e. So right now we can easily apply this Lambert W function. So as a result, what do we have right here? We have natural log 3 times 11 minus x. Here's our expression after applying Lambert W function. So natural log 3 times 11 minus x equal to this expression Lambert W function of equal to Lambert W function of 3 to the power 11 times natural log 3. Right now, what we're going to do next? First of all, let's look closely inside these parentheses. We have 3 to the power 11 times natural log 3. Instead of this 3 to the power 11, let's write 3 squared times 3 to the power 9. So instead of this 3 to the power 11, let's write 3 squared times 3 to the power 9. Okay, so right now let's do this. And let's change positions. Right here, let's write natural log 3 after these parentheses. So as a result, what do we have? 11 minus x times natural log 3 equal to Lambert W function of 3 squared times, we still have natural log 3, okay, we still have natural log 3, and times 3 to the power 9. Okay, so I hope you understand this step. We just write this 3 to the 11 as 3 squared times 3 to the power 9. Right now, let's write this 3 squared. As a result, what do we have right here? We have 11 minus x times natural log 3 equal to Lambert W function of, right here we have 9, so we have 9 times natural log 3, and right here we have 3 to the power 9. But instead of this 3 to the power 9, let's write very tricky expression. So instead of 3 to the power 9, let's write e to the power natural log 3, all right? So instead of this 3, we write e to the power natural log 3, but we need to raise this to the power 9. So instead of this expression, 3 to the power 9, we're going to write this one. It is absolutely the same. So we have times e to the power natural log 3 raised to the power 9. All right, so I hope you understand this step. This is like basic school properties. I hope you understand this step. We just write this 3 to the 11 as 3 squared times 3 to the power 9, first step. And second step, we're gonna write, instead of this 3, we're gonna write e to the power natural log 3, and we still have this 9. So I really hope you understand it. Right now, what do we have as a result? Right here we have 11 to the 11 minus x times natural log 3 equal to Lambert W function of, right here what do we have? 9 times natural log 3 times e to the power 9 times natural log 3. So we can easily raise this to the power 9. So we have e to the power 9 times natural log 3. Okay, and right now let's look closely. What do we have? 9 times natural log 3, and right here we have 9 times natural log 3. So going back to our definition, when we have Lambert W function of a times e to the power a, as a result we have only our a. So in our case, on the right side we will have only 9 times natural log 3. So let's do this. So we have 11 minus x times natural log 3 equal to, right here we don't have Lambert W function right now because we have only 9 times natural log 3, 9 times natural log 3. And right now, like the greatest part of all equation, we can easily cancel this natural log 3. And as a result, we have like a basic school equation. So 11 minus x equal to, right here we have 9. And I really hope you know how can we solve this equation, because from here x is equal to 2. I really hope you can easily solve this equation. Okay, and right now let's check it. Let's check this root. I think like a lot of students, can easily solve this question by inspection, because this is not that hard. What do we have in the beginning? We have 3 to the x, we have plus x equal to 11. I think like 99% can easily solve it by inspection, because this is not that hard. We can easily get the root right here, because when x is equal to 2 we have 9 plus 2 equal to 11. I agree with it. By inspection, you're a really great guy who can easily solve it like in a few seconds. But what about the solution? Because in terms of math, it's really great to know about solution method, and I think like a lot of students don't know this method according to Lambert W function. So I really hope I help you with something. I really hope you learned something new. So right now, what do we have right here? 3 squared plus 2 equal to 11. And of course this is a correct expression. So our final answer is x equal to 2. Right now you can see a graph, you can see this point of intersection. So I really hope you learned something new. I really hope you understand something new, which is also really great. Inspection method is a great method for everyone, but to check a root, not about a solution, because according to inspection method, you can't solve this question completely, fully, and you can't like guess how many roots you will have right here. But as you can see, in terms of like this is a great function called Lambert W function. In terms of this function, you can easily get how many roots we'll have. In our case, we have only one solution. You already saw a graph right here, so it's really great. So thank you everyone for your time. I really hope you understand my explanation. I really hope you learned something new, but definitely don't feel bad if you got this wrong. If you need help with any of these classes, I have a lot of questions on my YouTube channel. I have a lot of videos, so I really hope you will enjoy it. Thank you everyone for your time. Wish you all the best in your life. Thank you for your time, and have a great day.